This is the Cyber Operations and Risk Management Briefing by Jeremy Michaels, Sierra Williams, Alexander Withrow, and Eric Sue. The Australian cybersecurity team must identify a number of factors to create a secure computer information network that will not compromise the Five Eyes network. This includes identifying software assurance needs, key parts of the software development lifecycle, any risks with the acquisition process of the supply chain, and vulnerabilities of existing software. We will also discuss software options, supply chain options, and what costs we are considering for these recommendations. We will then close with language we should include in future contracts to prevent risks to the supply chain, the operations process, and the Australian computer network software. Software assurance is a means of instilling confidence that software and services are free from intentional and unintentional vulnerabilities. The software must also perform as intended. Expectations for the Australian computer network within the Five Eye Economic Summit and beyond can generally be broken down into 4 rules. First, avoid installing software which has malware already installed. Second, make sure that no vulnerabilities or exploitable parts of the source code are in the code prior to having the software accepted for operations. Third, and sort of a build on to this, make certain that future discoveries of any common vulnerabilities and exposures can be readily patched. And finally, make certain that these exploitable software weaknesses put the stakeholders of users the most at risk are mitigated before they are accepted for operations. Development of the Australian computer network relies heavily on the phases of the software development lifecycle, or SDLC. The basic phases, which are the fundamentals of Australia's development model, are as follows. The requirements gathering for software phase asks why Australia's State Department needs to create the software's purpose or what it will do, and who will use it. The software development team examines the requirements of the system, its function, and its restrictions. The design phase concerns how the software accomplishes goals that are encapsulated in its design. This maps theory into reality by outlining how the package will accomplish the goals set in the previous requirements gathering phase. The development phase applies programming code to specify requirements in the previous phase and integrating the programming code with what existing libraries or databases that already exist. Computer-aided software engineering, or CASE, tools are extremely helpful in this step because it performs heavy lifting for programmers who develop the code, test the code, and debug it. CASE is any software tool that automates the development of software. But the software also edits, analyzes, and upgrades the code's version. The testing and validation phase is a combination of verifying the software is written correctly and validating it works as planned, and the goals from the requirements gathering phase are met. Unit tests should be conducted on various inputs with which the code should be exposed. A different group of people should conduct the formal testing from those who develop the code. This is separation of duties, and it will prevent a conflict of interest, as the developers will want their product to be successful. Security tests should be made to identify at least common vulnerabilities identified within web application security risks discussed earlier. Buffer overflow should be attempted, denial of service and distributed denial of service situations should be tested, and unexpected input should be tested on the Australian server's ports. Unusual user activity such as unauthorized access should be attempted. If the new Australian hardware, which is the servers and end user device computers, laptops, and cell phones, crash, then the new software should revert to a secure state. The release and maintenance phase is Australia's server and host software prepared for operations or deployment. But it does not end with deployment. It must also be properly configured to the existing hardware, security patched on a regular basis, and monitored so that its performance is maintained for optimal performance. Once the software is properly tested, it is released so that it can be implemented in the overall production environment, but new vulnerabilities are still identified. The Australian cyber team, as well as State Department officials and secretaries, can still run into unforeseen issues such as unexpected errors when installed on a laptop, which is connected remotely to the Australian network and it has virtual private network client installed. The supply chain is the set of software suppliers or vendors who contribute to the system of hardware and software or who can modify the content. Considering the Australian computer network supply chain risks, there are several sources to identify. The following sources might interfere with the product's ability to function reliably, safely, and securely. Acquirer capabilities pose a risk because the requirements and proposals set by the Australian State Department for acquired security properties might not be initially addressed. Supplier capabilities are tricky because this is to ensure the supplier has good security development and management during the software development lifecycle. But this takes an investigation of the supplier's internal control, or basically an accredited auditor, which is a time-consuming process. Product security is compromised when the product itself will have potential for security compromises. For example, when the Windows 10 Pro package is patched and updated by the Australian developers and delivered to the State Department, we are assuring that its identified vulnerabilities were patched as well. Product logistics are a risk while the product is in transit or delivery to the State Department. Methods to guard against the introduction of malware into the product must be considered. Operational product control is when the configuration and monitoring must remain consistent and active as the product evolves over time. This includes maintenance on the product. A network that is used by multiple nations with potentially competing interests to transfer sensitive information faces very significant internal and external actors and challenges. Shoring up vulnerabilities and understanding the inherent risks of a system are critical to the confidentiality of data and stability of the system overall. Any network is at risk from a nation-state actor with a variety of motives and techniques. A network that is known to contain sensitive information is at even greater risk from more determined adversaries. A network that is used by multiple nations with potentially competing interests to transfer sensitive information faces very significant internal and external actors. Vulnerabilities are the absence or weaknesses in safeguards within the Australian computer network that can be exploited. The Australian Five Eyes Summit computer network has vulnerabilities which leave it subject to the following types of attack. Distributed denial of service, or DDoS, attacks are used when multiple computer platforms called zombies or bots are utilized by an attacker. The attackers hijack these computer systems with malware. As a part of the infection of extracting information such as bank records or passwords, the malware also connects the victim's computers to a command and control network. This command and control network launches thousands, perhaps millions, of packets to overload a targeted computer server or network. This will slow down the network and prevent legitimate users from accessing the network from the outside or for those on the inside of the network to reach outside destinations. Data in transit attacks, or data in motion, or man-in-the-middle attacks, occur when data is modified by a third party or external actor through interception on the network. The altered version of the data packets is relayed to the intended source. The integrity of the data is then compromised. The intended source receives basically the malicious packets, which then is forced to extract more information or to conduct an exploitation on the intended target. Malware is malicious software spread by email, sharing documents and media, or downloads. It takes the form of viruses, worms, Trojan horses, and logic bombs, and the Reviton ransomware virus, which infected the Five Eyes network at the Economic Summit, is one such example. This particular malware, called ransomware, encrypts a portion or all of the victim's files in order that it is inaccessible to the user. Keys are given to the victims only after they pay a ransom in the form of cryptocurrency. Given the high-profile nature of the summit, crippling the accessibility of State Department data is devastating. Cross-site scripting attacks occur when the attacks discover a website vulnerability and are able to inject their malicious code into the application. When unsuspecting users visit the infected web page, the malicious code either redirects them to an altered destination to exploit them further, or the malicious code will execute on the user's browser. This results in stolen cookies, malware execution, or hijacked sessions. Phishing is a social engineering attack which is usually carried out with fabricated email messages. The intent is to have the recipient or victim click on the malicious link provided in the email, or for the victim to send the attacker any personally identifiable information such as date of birth, social security number, or credit card numbers. This email is sent from a trusted source to many victims at once to maximize the attacker's profits. With technology progressing every day, applications are now gradually becoming more at risk with system vulnerabilities. Internet applications, for instance, enter internal databases with profitable data so that they are of a main focus to intruders. Customary system detection and protection systems are not intended to shield governments from application vulnerabilities. Building application-specific intrusion detection and prevention systems are a major way to capture systems vulnerabilities. These are web applications such as firewalls that use anomaly-based and signature-based technologies to identify commonly used attack methods. Anomaly-based devices intend to identify and foresee zero-day risks by distinguishing system movement that is abnormal, keeping in mind the end goal is to stay away from false positives. The system must perceive movement changes that happen through the span of the day and at various occurrences of the month. Packet sniffing analysis with Wireshark shows the actual traffic on a network. The captures may show that more data on the network user is exposed than intended, encryption issues, or unauthorized network traffic. Analysis may also reveal openings for the existence of man-in-the-middle attacks, replay attacks, or distributed denial of service attacks. To maintain a baseline of registers and images of data, the next step would be to implement an application configuration baseline on the server network itself. Apply the most secure version of the application with whichever system is being used, the highest the Windows 7 operating system can manage if you are unwilling to upgrade to Windows 8 and beyond. In light of possible disasters, Team Australia would hold image snapshots on its servers time-stamped each day at midnight Eastern Standard Time to maintain continuity of operations. The captured images will be held on a standalone system. Recovery operations in the event of a compromised system will entail pulling the image with the previous 24 hours capture, a re-image of the system, and updated patches from Microsoft and the Australian cybersecurity team's updated baseline. Cloud storage is another viable option. Before deciding on which cloud provider is best for the enterprise, it is vital to make sure that the provider is fully aware and committed to your objectives. Your objectives should be specific and geared towards the enhancement of the enterprise. Being as though the enterprise is rather large and converting a mass amount of confidential data, the cloud provider chosen must be responsive and have a dependable emergency backup cloud computing plan. If your cloud provider is not reliable, it is possible that you can lose an ample amount of your client's data if an attack or crash happens in the system. Once you are converting this information over, you can use tactics that will be essential to helping avoid breaches such as encryptions. Encryption is used to transfer simple data into an unreachable format or ciphertext. The ciphertext can be transformed back to the original format by using decryption. This promotes security and ensures that information can only be accessed by authorized users. Hence, it is widely used by businesses, institutes, and organizations to securely store and transmit data, maintain confidentiality, and provide restricted access. The National Institute of Standards and Technology's guideline document describes the use of encryption for stored data. The benefits of network intrusion prevention systems are they detect and stop attacks that most other security controls cannot manage to do. They can also be tuned via customization to detect capabilities to stop activity of particular concern. They significantly reduce the amount of network traffic reaching other security controls. This does two things: lowers the workload for those controls, and it protects those same controls from direct attacks, like a type of buffer. When trying to quantify the cost of an intrusion prevention system, the average cost per stolen or hacked record in 2017 was $141. Now, these are personnel and business records. This number adds up tremendously when you're dealing with gigantic firms such as a multinational bank, where thousands of records breached will have a significant impact. But what would be the cost if a government State Department had no network protection? The most immediate threat would be national security, not just for the Australian State Department, but the other governments within the Five Eyes network, because they are also sharing their information. Other significant costs would be a loss of personally identifiable information, or PII, confidential information on other state departments, upgrading software and hardware that should have already been upgraded as well. Those are opportunity costs for not having been done in the first place. Also consider system downtime and how this would affect the valuable time of the Five Eyes conference, staff time to investigate the breach, the legal repercussions involved, and the public relations fallout. Wireshark is a very apt option to use for the Australian computer network because it conducts packet sniffing analysis to show the actual traffic on a network. This capture may show that more data of the network user exposed than intended. Encryption issues or unauthorized network traffic are also exposed. Analysis may also reveal openings for the existence of man-in-the-middle attacks, replay attacks, or distributed denial of service attacks. This also runs on most computing platforms such as Windows, Macintosh operating system, Linux, and Unix. Wireshark's cost to the Australian State Department is minimal, if any. This is because it is a public open source system. This is a conglomeration of network engineering and cyber protection around the world, which provides identification of any number of risk attacks to the computer network. This can only benefit the Australian cyber team in its network defense efforts. The benefits of cloud implementation would be that the expenses can be significantly lower, giving organizations the choice to add or remove IT capacity to meet administration requests while paying for what is only utilized. The enterprise can lease additional server space for time needed instead of keeping up with the new servers and expenses. They additionally have the adaptability to have their virtual IT framework in areas offering the most reduced cost. Also, using a cloud, there would be no hardware or software establishment to upkeep. Improved IT framework gives quick admittance to required registering administrations. The costs of computing resources and clients in a cloud computing atmosphere is there is a target for security threats and vulnerabilities. Due to their size and substance, cloud providers are frequently targeted by computer-generated machines and bot malware, brute force attacks, and other attacks. Gather information from the cloud provider about access control, weakness evaluation practices, and patch and procedure management controls to see that they are sufficiently ensuring your information is protected. A properly managed supply chain, from raw materials to production to distribution to transportation to the customer, is crucial to acquiring products clean from tampering. Electronic smart seals, such as CYB's lock and encode smart seals, are radio frequency identification, or RFID, enabled, and they provide physical and electronic tamper tagging solutions. This type of seal is designed to secure containers which ship information technology assets and high dollar value items. These ultra-high frequency, or UHF, RFID smart seals provide a combination of long-range radio tracing with both insert and cut sensors for its cables. This reduces loss in transit. This also tracks time and location when tampered with. Finally, it provides automatic order and shipping validation at each port of entry or departure. This will ensure product security and product logistics and supply chain risk management are covered while in transit to Australia's State Department from overseas. Cargo insurance and tracking is necessary because should there be any loss or damage to the cargo, insurance will save the lengthy administrative process of reclaiming damages with no guarantee of the outcome to the loss of taxpayer money. Insurance providers like CMA CGM Cargo will provide broad coverage from damage or loss including stranding, grounding, capsizing, and sinking while in transit. Other problems such as theft, pilferage, and non-delivery of the goods or malicious damage or tampering and loading or unloading operations will also be covered. Acts of God, such as earthquakes, lightning, and hurricanes, are also applicable to cover the costs of the loss of the merchandise. Something that is principally lacking is training of personnel on courses related to coverage of security processes with software security. High-value practice activities such as abuse case analysis, risk-based testing in software, architectural risk analysis, and code review practices and tools to prevent tampering of software and to find any malware need to be in place. The Denim Group is one such organization which specializes in thread-strong secure software development and testing courses. Australia's State Department and cyber incident handling teams will only be augmented by these courses of instruction on how best to deploy and maintain its software to prevent future risk from the supply chain. This process will cover the operational product control supply chain risk, which covers configuration as well as monitoring of the software product over the course of time. The only quantifiable cost to all of this is the merchandise for the Australian computer network being shipped in 4 containers. An estimated cost of $465,000 can be placed on all of this equipment. This is compared to the cost of 4 CYB lock and encode smart seals at $8,000, which is 4 apiece for $2,000. The insurance and tracking costs of the merchandise is quantified at $25,000. Finally, the training of approximately 25 personnel in 2 major ports of entry and debarkation for the shipment of goods is $100,000 over the course of a year. This training also covers the thread-strong secure software development and testing courses, as well as the code review practices and tools to prevent tampering of software and to find any malware. It's fairly expensive, and this is to train them on monitoring the security and other issues involved with the software itself. The result left over is $332,000, which is quantifiable. But the non-quantifiable cost is the damage done to the State Department and the 5i network if this merchandise is somehow tampered with. Now that we have covered vulnerabilities in software and the supply chain, the Australian cyber team and the State Department must consider how it should make a contract with companies in the future to curtail these issues as well as security and operations. The team must ensure that supply chain vendors have procedures that are expressly stated or codified, as well as certified by an auditing authority such as a reputable accounting firm. These certifications can also be verified from accredited auditor reports such as the Health Insurance Portability and Accountability Act, or HIPAA, business associate agreements, or the payment card industry audit. In-house testing of third-party systems and how they operate will also attest to their validity and reliability. To cover any case of breach, contracts should be drawn up between the Australian government and the relevant vendor or vendors to express the use and access guidelines to properly allocate liability. These contracts should require the supply chains to inform vendors or any stakeholders of breaches in a timely manner. This will prevent tampered software, hacking business data, or prevent further invasion. There also must be incident response plans ironed out between both parties. There needs to be a plan for each party of the supply chain to notify the other if systems, network, or data have been compromised, or even if there is suspected compromise. Data ownership or stewardship requirements in the contract need to establish who maintains the data and what means are considered acceptable for data usage. Sensitive business or personal data might be needed to contract between two or more parties, and a compromise in one or the other is a liability, eventually to everyone involved. Regulatory business compliance, especially on an international scale, needs to be met and maintained by both parties when it comes to privacy as well as packaging and shipping standards of products. Finally, information and communication plans which address what information goes to whom are strongly recommended, as third parties are now considered a part of the Australian Computer Network's IT security, at least to an extent. Their organization is a part of ours, and during software development lifecycle, and as such, some State Department information can be of extreme risk. In conclusion, needs and expectations of the Australian Computer Network regarding searching for malware and discovering commonly known vulnerabilities were discussed to make certain they were patched in the future. The 5 phases of the software development lifecycle and how to apply them to the Australian project development were also discussed. The supply chain and the 5 risks were also discussed. These were acquirer capabilities, supplier capabilities, product security, product logistics, and operational product control. Existing vulnerabilities in the Australian Computer Network are distributed denial of service attacks, data in transit or man-in-the-middle attacks, malware attacks to include the Reviton ransomware virus, cross-site scripting, and phishing attacks. Software options and recommendations are the installation of network intrusion prevention systems, Wireshark for packet sniffing, and cloud storage to minimize hardware and software overhead. Costs and benefits to the software recommendations were weighed and considered to allow for these solutions. Software supply chain risk solutions include advanced cyber lock and encode smart seals, designating proper insurance for shipping the product to Australia, and training personnel in software security. For future contracts, supply chain vendors must have a certification in their internal control, and contracts of liability must be drawn up between 2 parties. There must be incident response plans regarding cases of breach, and data ownership must also establish who maintains the data. Finally, regulatory business compliance and information and communications plans must enforce standards of privacy, packaging, and shipping and control what information goes to which member in the supply chain. Thank you for watching this presentation on Team 2 Australia's cyber operations and risk management.